Hi 8th grade, this is Miss B here with lesson 5.1. We're going to begin by going over our do now. For our do now, we have a multi-step equation in which we are asked to solve for x. So we have a lot of things going on here. We have fractions, we have decimals, we have brackets, and we have parentheses. So the first thing I'm going to do is convert each of these terms to be either decimals or fractions. So because most of them are already in decimals, I'm going to go on ahead and convert negative 1 over 20x to a decimal. So if you put negative 1 divided by 20 into your calculator, it will give you negative 0.05, and we have our x. So I'm going to recopy everything I have on the left-hand side. Looking at the left-hand side of our equation, we know that we have to somehow eliminate these brackets and the parentheses. So we're going to start by working from the inside out. So notice that we have a negative in front of the parentheses here, which means we have a negative 1. And we are going to multiply each term on the inside of the parentheses by negative 1 in order to eliminate them. So now that I've gone ahead and distributed the negative 1, I need to somehow combine my like terms so that I can eliminate the brackets. So we're going to combine 0.8x minus 0.2x since they are like terms. Notice that we have a negative or positive 0.25 in front of our brackets. This means that we must distribute 0.25 in order to eliminate those brackets, since combining our like terms didn't do it in that step. So we have finally gotten rid of those brackets. So now we have a two-step equation. So we're going to bring our variables over to one side of the equation and keep our constants on the opposite side. So because I have a smaller coefficient on the right-hand side, we can go on ahead and add 0.5x on both sides, but we'll be left with a 0 here, which means we'll need to take an extra step and bring our constant over to the right. So I'm going to go on ahead and bring 0.15x to the opposite side by subtracting it on both sides of the equation. So this is going to cancel out, and we're going to be left with negative 0.2 is equal to negative 0.20x. So now that I've got my constant on one side and my variable on the other, I'm going to divide by the term that's in front of the variable, or the coefficient, which is negative 0.2, to solve for x. So this is going to divide out and turn to 1x, and negative 0.2 divided by negative 0.2 is positive 1. So x is equal to 1 for our do now. Today is our first lesson on our new unit, and today we're going to be finding the area of complex two-dimensional figures. So with complex two-dimensional figures, we're just going to have more than one shape, such as a triangle and a circle and a rectangle, combined together. So let's take a look at one example, and let's refresh our memories with the formulas for basic two-dimensional shapes. We're going to fill this out together, and this is going to be your reference sheet that you're going to use to help you find the total area of the images that you have today. So the area of a rectangle, should be an easy one, is just the length multiplied by the width. So right next to our rectangle, we're going to say the area is equal to length times width. The area of a square would just be the same thing. The only thing with a square is that our sides, all four sides, are the same. So we can say that the area is equal to one of the sides squared, right? Because we would be multiplying the same number by itself. When it comes to a triangle, now there's a reason that we have two different triangles on this sheet. For some triangles, if they're not at a right angle, we're going to be taking the vertical height, which goes from one point at the top to the base. So this would be the vertical height of that triangle. In a right triangle, we're going to be looking at the leg that's going straight up and down as our height. So either triangle that we're given, its area is going to be equal to the base of the triangle multiplied by the height of the triangle divided by 2. And the reason we divide that by 2 is because if you think about it, a triangle is really half of a rectangle. So if I were to complete this image here and I asked you to find the area of this rectangle, you would do the base times the height, or the length times the width. And if we wanted it to turn into a triangle, we would be taking half of that area, which is why we're dividing it by 2. So that's where that formula comes from. Circle's a little bit different. The circle, the area is equal to, and we're going to use a special number, pi, which is approximately 3.14. So the area of a circle is equal to pi times the radius squared. So when you learn circles, when you first studied circles, there are two very important parts of a circle. We have what's called the diameter, which is the distance from one end of the circle going through the center to the other end, and we have the radius, which would be half of that. So from the center of the circle extending to one of the sides. So that would be our radius. And we are going to work with a few trapezoids today. So the area of a trapezoid is taken by adding the first base and the second base, because we have a top and a bottom, so we can say this is base 1, this is base 2. And we're going to take its sum and divide it by 2. We're going to cut that number in half and then multiply it by the height. So the height of your trapezoid will always be given to you. It'll be a segment where it looks like it's creating a triangle on the end. So this would be our height. So we're going to go on ahead and look at some shapes and apply these formulas to find the total area of the shape that we're given. You are going to be using rulers today. You're not going to be rulers, you're going to be using rulers. So we're going to use centimeters, and you're going to round to the nearest quarter of a centimeter. In the first three examples, you're going to be given composite shapes, which are made up of circles, squares, triangles, and trapezoids, any combination of those, and it's your job to try to see what type of shapes are within that one. So if we look at this example in number 1, I see that I have a curved portion on the bottom over here. So I know that I'm going to be using some type of circular shape. And that's going to be a semicircle. So what we're going to do first is actually divide this larger shape up into different images. So we have our semicircle on the bottom, and if you notice, at the top we have a peak, so we're going to have some type of triangle. So we have a right triangle at the top. My line was a little crooked there. Make sure you use your straight edges. So I have a triangle, a rectangle, and a semicircle. So we're going to find the area of each of these shapes and add them up. So using your ruler, go on ahead and measure each dimension of the shapes that we're given. So for the triangle, we're going to need the height and the base. And the base for that triangle is also going to be one of the side lengths of our rectangle. So we'll also need to find this side of our rectangle. And again, since it's a rectangle, opposite sides are the same, so that would give us the diameter of our semicircle. So pause the video, take a moment to use your ruler, and unpause this video for the answers. Take a moment to copy down or match up your answers with what I have here. I'm going to erase it in a moment so that I can actually show the work on the empty space that I have.